So here's what we're going to kind of run into now. We have permutations with repetitions. So when we're looking at words here, if you have repeating letters, we can't really tell the difference between one A and another A. So it's going to change the formula we're going to use a little bit. So we're going to look at something where I have a total of n objects, where P and Q are alike. Then we do n factorial divided by P factorial Q factorial. So n is still going to be my total, and P are going to be my repeats. My P and my Q are my repeats. Let's go ahead and look at an example of this. How many ways can the letters in the word Mississippi be arranged? So the first thing we need to figure out is how many total we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total letters. So I have 11 total. And I need to look for repeats. Well, we know that we have multiple I's. I have 1, 2, 3, 4 I's here. So I have 4 I's. Another repeat letter we have is S. So I have 1, 2, 3, 4 S's. And then another repeat I have is the P. I have 2 P's. So that's P's. So what we're going to do for this is we're going to do the total factorial on the top. So 11 factorial divided by our repeats. Well, I have 3 different letters that are repeating, so I need 3 different pieces in the denominator. So each of these is going to be a separate factorial. So I have 4 factorial for the I's, 4 factorial for the S's, and 2 factorial for the P's. So we can go ahead and we can write this out. We have 11 times 10 times 9, 8, 7, 6, 5, 4, 3, 2, 1. And we can write out 4 factorial, 4, 3, 2, 1. 4 factorial, 3, 2, 1, and 2 factorial. So we can go ahead and we can cancel some things off. We know that multiplying or dividing by 1s doesn't change anything, so I can get rid of all these 1s here. 2 can cancel with a 2. I can have a 4 cancel with a 4, 3 with a 3. Now it looks like I'm kind of all done here, but keep in mind, a 4 times a 2, 4 times 2 is 8, so I can cancel those ones together. I still have a 3 and a 2 on the bottom, so 3 times 2 is a 6, so I'm going to cancel that. So realistically, all I have left to do is 11 times 10 times 9 times 7, because we canceled the 8, times 5. Everything else is canceled off. So when I go ahead and I do this in my calculator, I end up with 34,650 different arrangements. So let's look at one last example here before moving on to practice. How many ways can the letters in the word geometry be arranged? So again, let's figure out how many total we have. We have 1, 2, 3, 4, 5, 6, 7, 8 total. So I have 8 total. And then I have some repeats here. I have O that's repeating, or sorry, E that's repeating, and I have 2 of those. So I have 2 E's. Nothing else is repeating, so I'm just going to go ahead and write my formula from here. I have the total on top, which is not 11, that's for Mississippi. I have 8 on top, and then 2 factorial on the bottom. So when I do that, I get 8 times 7 times 6 times 5 times 4, 3, 2, 1, divided by 2 times 1, cancel everything out. So I have 8 times 7 times 6 times 5 times 4 times 3. When I do that in my calculator, I get 20,160 different arrangements for the letters in the word geometry. Go ahead and ask me any questions before moving on, but get your practice done.